Hey guys, Jacob Howard here, and today we are talking about flight controllers. This is another one of the printed circuit boards that is present in all drones. The flight controller is the heart of your drone and contains the primary processor which controls the general functions of all other components. Flight controller boards contain microprocessors and other various sensors in order for them to function properly. The flight controller essentially facilitates communication between all other components and tells them what to do. This communication between flight controller and the drone can be configured for different flying styles and preferences though. The way that the user configures the settings on a flight controller is through a firmware configurator on a computer. We will have an entire module on that, and we'll be teaching a configurator called Betaflight. Betaflight enables you to specify what roles the flight controller will play and how it will interpret signals from your transmitter, OSD, and flight controller. Flight controllers also house the on-screen display, or OSD settings. In most drone builds, having OSD capabilities in the flight controller is standard. The specific settings for the items visible in your OSD, like battery voltage or signal strength, are also configured through your configurator. Gyro. One of the sensors that are present on all flight controller boards is called a gyroscope, or gyro for short. A gyro is a microchip that records the speed at which a quadcopter rotates in each axis. Using this data and program mathematics, the flight controller can estimate the distance a quadcopter has rotated and whether its rotation is accelerating or decelerating. A gyroscope is required for the quadcopter to fly in acrobatic mode since the drone does not self-level in this mode. Accelerometers and flight controller. Most flight controllers will also integrate an accelerometer, which is another separate sensor chip. Accelerometers can detect the acceleration of your drone and the roll, pitch, or yaw axes. This includes the force of acceleration of gravity, which the accelerometer uses to tell the flight controller how to stay level with the horizon. This is used for flying a quadcopter in horizon or stabilized mode, which keeps the quad at a level orientation when the sticks are centered. Other sensors. Some flight controllers contain other sensors like barometers or current sensors. Barometers are used to measure air pressure and can record the relative altitude of your drone. This is used to prevent drones from going higher than they are allowed due to local regulations. A current sensor reads the power running from the battery and can provide useful information in your on-screen display. This is often used to know how close a battery is to being empty or how efficient motors are. There are currently no flight controllers with integrated GPS units. However, GPS units can be added to drone builds to improve long-range flying. In this case, a GPS unit would be purchased separately and connected to the flight controller and set up through the configurator. We will have another video covering GPS modules later in this course. Power distribution board. Like we mentioned in our video about power distribution boards, or PDBs, most flight controllers can now offer that system already integrated. If the flight controller you have or are looking to purchase has solder pads for electronic speed controllers, you can assume there is some form of integrated PDB. Integrated flight controllers. Flight controllers typically serve only the functions we have just mentioned. However, in smaller drones, the flight controller is often integrated with other components, like the electronic speed controller, which we will address in a separate video. In these instances, there is only one circuit board, but it still has the same processors and sensors and works in the same way a larger flight controller would. Flight controller processors. The main brain of the flight controller is called the microprocessor. There are various types of processors available. These are differentiated through a simple rating system, and each processor is marked with a value between F1 to F7. The number after the F indicates the speed and functionality a processor is capable of. The most common ratings you will see today are F4 and F7. For a simple racing drone, a F4 processor will work just fine, but if you are building a more complex drone with an integrated GPS system, for example, a F7 processor will be extremely valuable. Size and placement. Flight controllers are typically placed in the stack, which is at the center of the drone on 4 standoffs. For 5-inch builds, the spacing will typically be 30 by 30 millimeters. However, another common size is 20 by 20 millimeter. For smaller drones, custom size and shape flight controllers will be available. It is generally advisable to place the flight controller at the center of the drone to ensure best performance. This helps the flight controller record the cleanest data from the accelerometer and gyro. A common practice used in conjunction with flight controllers is soft mounting. This is where you would include some kind of vibration dampener between the board and the standoffs. Because the standoffs are rigid, small vibrations from the motors can be transferred into the flight controller and cause the gyro to report messy data, which decreases performance. Adding these small rubber vibration dampeners eliminates these small vibrations and allows the gyro to read only the true movement of the drone. Flight controllers also have an orientation, meaning that there is a forward and backward already specified. This is usually indicated by a printed arrow on the board. It is important to pay attention to this when mounting the board. PID. In order to have a high-performance drone, tuning will be essential. All pre-built drones come pre-tuned, and these tunes are usually pretty good. Betaflight and other firmwares also have stock tunes which are acceptable, but understanding the basics behind tuning is important. A common way to reference tunings is PIDs, or PID. PIDs are essentially the individual values and variables that can be adjusted to improve your drone's flight characteristics. P stands for proportional, I stands for integrated, and D stands for derivative. And these are all referred to as gains. Each of these P, I, and D gains can be adjusted for the 3 three axes: roll, pitch, and yaw. So there are essentially 9 key variables that can be changed to tune your drone. PID tuning can be very confusing and require a lot of trial and error. We will discuss PID tuning in more detail in the tuning and maintenance section of our course. In the meantime, it is important to know that drone performance can be improved through these PID values that are set in your flight controller. Solder pads. During this course, you will learn a lot about soldering, but while we are discussing flight controllers, it is important to get into some of the basics. Because everything stems out from the flight controller, it is important to know what connections or solder pads are available. In some cases, flight controllers may be equipped with connectors so that soldering is not necessary. For example, most flight controllers have the option to connect a 4-in-1 electronic speed controller without soldering. However, for most other components, soldering will be necessary. Most flight controllers will have at least the following connections: video out for a video transmitter, video in for the camera, electronic speed controller signal pads for each motor, and universal asynchronous receiver transmitters, or UARTs for short. For our purposes, UARTs are one transmitting and one receiving signal connection. It is important to understand UARTs because you will need to make sure there are enough for your purposes. One UART will have to be taken by your receiver for controlling your drone, and one is usually taken by video control or smart audio. If you are planning on using a GPS module, you will need one more UART designated for that. This is why we mentioned the importance of drawing a diagram of your drone components before beginning. It will help you have a cleaner build and ensure your flight controller has enough UARTs and the capability to perform the functions you want. Flight controllers are another very important part of your drone. It is essential that they are selected carefully and function properly. As we discuss other components and their functions in detail, you will begin to grasp the importance of your flight controller. If you guys have any questions, definitely let me know, and have fun flying.